this video, we're going to look at the question of whether there are any perfect squares of the form 1, some number of zeros, and then a 1. This could be anywhere from no zeros to 1 0 to 2 zeros to a million zeros. So this seems like a pretty crazy question, and how would you even, we're not sure how we would even address it. So one very powerful way to approach this is using mods. So the first time I saw this, I was pretty much in shock as to like how would I ever have figured this out, and this is why I'm showing this to you guys, so that if you see this in the future, you will have already seen it, so now you'll know this idea. So let's think, the hint is, let's think about mod 3. So where in the world did I get the number 3? Well, I designed the problem, so that's how I knew to think about it. All right, but now that you're going to be aware of these things, you should be able to think about them as well. All right, so let's think about perfect squares in mod 3. If we're dividing by 3, there's only 3 remainders, right? A number, if we don't know a number, it can be congruent to either 0, 1, or 2 mod 3. You can have a remainder of 0, so it's perfectly divisible by 3. It could really leave a remainder of 1 or 2. If it's a remainder of 3, same as 0. Okay, there's only 3 cases. Let's see what happens when we square. Now we're interested in perfect squares, so let's square x. So then these numbers become 0 squared is 0, 1 squared is 1, 2 squared is 4, but 4 mod 3 is also 1, right? So we only have 2 possible remainders, 0 and 1. 1's repeated. So the number we don't have in this list is the 2. Now if you look at this number with some number of zeros and use the divisibility rule for 3 and sum the digits, what do all these digits sum to? 1 plus 1, all the zeros don't matter, so that's 2. So this tells us the sum of the digits is 2, which is an impossible remainder mod 3. So without considering a ton of special cases, using modular arithmetic is a super powerful method for proving certain numbers can be or can't be perfect squares, among other things. So for those of you that want to study math further and get into some really heavy-duty proofs, using mods will be a very powerful technique that you can employ. Now there are other mods that have some interesting properties. I just picked 3 at random because I designed the problem that way. You can look at mod 4, where the remainders are 0, 1, 2, 3. If you square these numbers, you get 0, 1, 4 is the same as 0. 3 squared is 9. 9 mod 4 is 1. So notice, if this is not always going to be 0 and 1, but notice you don't get 2's and 3's. So we could have used mod 4 instead of mod 3, and this would have worked out as well. And if you play around with random numbers like 3, 4, you could try mod 9, mod 5. You might find that you don't get all the remainders. So by doing this quick little check, you can quickly tell whether a number might be impossible for it to be a perfect square. And this goes beyond just perfect squares. So this is a powerful technique. Check whether that remainder is even possible under a certain mod. All right, I'll see you guys in the next video.